I like
Wait, guys,
that.
starting, are you still planning? This is raised like.
No. Wait, I did do that. Okay, folks. If I could get your attention, please. Sure this is working. Okay, so completely new unit. This one is about trigonometry, so or trigonometric and polar functions. So completely different. What we're doing. Of course, will be some overlap, but new concepts, new beautiful concepts. I think you'll enjoy it. So decent length. You can see that there are two quizzes. One is on the 29th. The other one's actually Friday, February 6th. There's a typo there, so it's the 6th. These are already in the hub calendar. The test will be on the 12th. Yeah, February 12th, people like right before Valentine's. You're already. Is that the
So is the second one gonna be on day 7?
Yes, it is on May 7th, no, 2 days. Yeah, I wrote the quiz here and I forgot to include the quiz here, but there is a quiz here. There is a quiz here, so you may want to write that in your sheet here. I also want you to notice that this column, I think it used to be homework, so it was either blank or it had random stuff. Now it's labeled further explanation and problem resources. So if you want more practice, like before a quiz or a test, that is available for you. Now let me show you exactly what this is. The links on your paper are not clickable. If you could try it, but it's nothing's gonna happen. Yeah, sorry. Let's see. So I think I have to share this other one. Here we go. So you have to download it from the hub, and this is available for you on the hub. So when you click on this, it'll take you to a website called Flip Math.
Is this like the Pearson?
Which is kind of like Pearson, but it's not Pearson. Let me now make sure I'm showing the right thing so the people at home can see what's going on. You get to this one, and right now we're in 3.1, like it says in the syllabus. The 3.1, you just click on that, and that'll give you lots of options for like a packet. I think it may be the same packet that we have. I'm not sure, honestly. I think there's like explanation. That video will actually teach you how to do some stuff if you're not sure. Yeah, Max.
So are we expected to like this and solve it, or like do
No.
we need a turning?
No, now remember, great question. This is just an extra resource. I think that what you may be looking for, if you're looking for this, is a corrective assignments. I don't know how to call it corrective. I think it's assignments that could be corrected. It's just more problems. That's probably what you're looking for, or further explanation in the video. So this is just available for you. Yes, Simran?
It says quizzes February 5th.
Yeah, show me the 6th, the type. Thank you. Good catch.
Oh,
Yeah, nice. Yes,
you'll just keep telling us the homework.
Yeah, I'll tell you on a day-to-day basis. It's mostly going to be, I'm going to try to make most of it Pearson. I prefer when it's on Pearson. Tonight's will be from the homework packet. Now, you didn't get a homework packet, right? Yeah, I would remember. That was just a couple minutes ago. I hope I would remember something like that. I decided not to print out a homework packet. It seems completely inefficient, especially if I'm not going to be assigning homework from there every time. But sometimes there are just 2 problems on a page. And that's just, there was 47 pages long, this homework packet. It just doesn't make sense to print it all out and hand it to you. So I'm just going to ask you to, save the trees. Save the trees. And the early bird gets the worm. Okay, don't forget about that. Yes, Haley?
Submit the packet from last week.
Only if I ask. Yeah, other than if nothing, if I'm just checking the Pearson, and if I ask, if I'm concerned, then I'll ask you for your paper work. But yeah, so the homework packet is on the hub. I expect you, like tonight when you do the homework, label it 3.1 and just write whatever work and answers you need to write. And the answers are also on the hub. Yeah.
Is the packet that's downloadable here the same one we have, or is that extra?
Let's see. I don't know. Do I have access to that? Do I have to go back here? Oh, wait, I was just on that page. Let's see what it is. Dun, dun, dun. Oh, it's different. It's different. So you get another angle. Yeah, that's exciting. Thank you for asking. Okay. Um, I think so. You all understand where to get the homework from if it's not Pearson. I'll be very specific on a day-to-day basis about where to look for that. And I will try to give you Pearson. That's my preferred method of delivery. But the book doesn't always match what we do in class, so it doesn't always work out as hoped. Okay, so let's get to the packet. Nope, that is not the packet. That is a Word document. I got fooled. Oh, this has this thing where if something is maximized, it doesn't recognize it.
You know, I went to somewhere and they were saying, because I told them my name is Maximus, they were like, Miss Maximus.
Oh, that's nice. Is it visible now? Yeah, here it is. Okay. So let's get to the packet. And again, I urge you all to put these in a 3-ring binder. If you don't have a 3-ring binder, you definitely need to staple these, otherwise it gets to be a mess. So make sure maybe later today you'll do that. There should be a Unit 3 packet. I'm sorry, a Unit 3A packet. Pass it. Oh, they're not passing. Oh, thank you. I passed out the assignment sheet and forgot to pass out the packet. Thank you. Here's the packet. And if you would like to staple it now, you can do that. There's a stapler up in the front. Of course.
Yeah. Bro, I need to buy me. Allie, I heard the name from the podcast last week. So.
But I wanna get it done.
You got it? Unfortunately. Well, I'm gonna do it.
Actually,
So it's
are you bilingual?
I might be trilingual.
What do you?
I tried to be.
trilingual.
I like that.
You like.
I'm just
I'm bilingual too.
I'm just your family neighbor. I wish I did.
Thank you so much.
Rap. Did it say?
What's your third language, Mr. Lieberman?
my third Spanish. Pero es muy malo.
It's a second.
Japanese. Yeah. Are you 3-ring binder haters?
I have three language.
Say it again. Watashi wa
Wait, what does that mean?
そうですか? Watashi wa American desu. Speak the Nihongo. Miley does too. I heard it today. At least one word. Yeah. Hi.
Actually learned that.
Hi. I lived in Japan. Yeah, a couple of years. It's a good way to learn a language. Yeah. What? Does he speak any Japanese? Sugoi ne. Tell him that. Interesting. We'll have to talk about that. I still need to show the right. Sorry for those of you at home for that side conversation.
I like this.
What's going on? Oh, I see.
Yeah. Is it like?
Okay, folks. Packets. What a hold up. Okay, here it is. The functions that we're going to be studying in this chapter are something called periodic functions, which means each one has a period. And that's not like a grammatical period where you just have a little dot at the end of a sentence. It's completely different. Period, just like in time, a period of time is something that repeats. So a periodic function means there's a chunk of that function that you could select copy and paste again and again and again. And normally it's forever, from negative infinity to positive infinity forever, like periodic forever. So this gives us a little piece of the function, but do you see that this is periodic? Or could be periodic? It's repeated. This specifically has what's called a period of, did you see, what do you think the period would be here?
Of 4.
Does it make sense that it's 4? It's the smallest like horizontal unit, yeah, that is repeatable. So if you just look at, I think that many of you are looking at this, is that right? From -1 to 3? Is that what you looked at when you said it's 4? Or you could be looking maybe from 3 to 7, there's 1 unit. Or would it make sense to look at this for one period from 0 to 4? It's a little awkward. I don't think but you could do it. Like you could actually copy and paste that portion and put it over here, put it over 1 to 4. It could be awkward, it'd be super awkward. Like starting in the middle. So I think -1 to 3 or 3 to 7 is a good place to see the periods. But either way, we would say that the period is 4. And this sounds familiar from last year when you studied what functions? Sine and cosine. Those have periods, right? And we'll be studying those in just a moment. Don't you wait. It's going to be amazing. Okay, this question out in example 2, it says this is periodic. So would you please show me what the least possible period is for this one? Show me what it is. And hold it up when you know.
2, 3, 4, 5. Wait, no, not like
It is a period of 5. And if you're not sure about where that came from, maybe you could discuss with your name. Yeah, similar.
So period is just the x values, like for when it repeats.
Exactly. Yeah.
Oh, so how many units it's for one sort of. I don't know.
Perfect. Yeah. How many horizontal units we need? If you're going to select, copy, and paste, make it happen again. Now, if we said that the period is 3, that'd be completely wrong. Do you see what would happen if we chose that as a period?
It'd be like
Yeah, it'd be like a sawtooth, wouldn't it? It would just do that again and again and again. Well, I think that this asks, actually, I forgot, draw 2 additional periods for the graph of f on the axis above. So go ahead and do that. So you can check with your partner, or you could check up here. I'm going to do these in red just to be a little bit obvious.
But you can also say that it's the absolute value.
I don't know about that. Maybe sometimes.
Oh my gosh, I totally forgot about that.
Yeah, there might be some absolute values going on here. I put a little bit on the left just because. But you all have that same thing, don't you?
Yes.
Uh-huh.
Okay, I believe it. Okay, so we talked about this. The least possible is 5, definitely not 3. So please think about just A for now, just A, and once you know what GF14 is, discuss the neighbor. What is it? And this is G up here.
It's on the period.
I just said 14. Right?
Yeah.
That would match like the the graph on the would be six.
Would you please show me what GF14 is? Show me what you got for GF14. Okay, so I'm seeing 25, is that right? Okay, 7. Okay. I want to hear just your thoughts on how you got that. Jonas, did you get 7 for this? Did you get 7 for your answer for GF14? What did you get? It seemed like you were focused on breathing or something.
Sorry.
That is important.
Okay.
It's important to breathe. Go on. What is that?
There's something stuck in here trying to get it out.
I see. Okay, well, make sure to focus on material. Okay, Nia, do you have an idea here? Did you get 7 for this? And were you also focused on breathing, but you're able to do both? Okay, locked into breathing and this problem, I hope. Yeah, don't lose that breathing thing. Very important. Okay, how did you get the 7?
X is 1, 2, 3, 4, and 5.
Mm-hmm.
That was the end of like the period of 5. That was the value of the period.
It's like a fundamental set, right?
Yeah.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Okay.
And
Okay. So it sounds like you're counting in 5s, right? You did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's kind of like the same thing as G of 4. Kind of like that. Was anyone thinking the same as G of 4? Perfect. Thank you. Anyone else want to talk about how they thought about this, like where they got that 7? Yeah, Emma?
Like, couldn't you also do like 14 divided by 5? And look at the remainder, which would be 4.
Ah,
So you could also look at when G of 4, and that's also 7.
does that make sense? Right, since the period is 5, so divide that number by 5 and whatever's after that. Okay. And I'm gonna write that down. I really like that. That is what the book, not the book, but the lessons kind of point towards. So something like this. So there are 2 groups of 5 with that 4 as a remainder. So this is equal to G of 4, which we know by looking is 7. Did anyone think about this a different way? And if no, for me, I would have just counted back 5. Did anyone count back like to G of 9? No one did that. I'm alone in that. Okay, that's fine. G of 9 is fine, because I know that's the same thing as G of 4. Okay, so I'll give you a moment to work through B and C if you haven't already.
Well, 72, I thought it was like.
75 and then you get like,
you get 12 remainder.
Right.
Or no, you get 14 remainder too. So you go to the end of the spreadsheet.
Negative 10.
Right, and you go.
And then you have 72. I just put it actually, it's like. So it's 70 of 3.
I don't know.
5.
You get those two.
You have 2 is 7. G of 2. Oh, wait, no.
All
All right, we got 6.
All right.
7, 6, 7. Yeah, I've done 7. I don't know if 7's right for B.
Yeah.
You're doing B and C.
You go back.
You divide them.
Sure.
I'm writing myself. I can actually.
I'm calling you.
What?
I will be calling on you.
What?
I will call on you.
That is
Okay. So redemption time. Jonas, help us out with B. What'd you do?
So you kind of do the same thing. You say that G of 72 is the same as G of 2 plus 2 times 35.
2 times 35? I don't know if we care about the 2 and the 35.
I don't really care about the 2 though, so
I'll give you the 2 and then we'll talk about the rest.
but it just basically equals G of 2, which equals 6.
Which is equal to 6. Do we agree that equals 6? Okay, nice. Now you're right. It does equal 2 times 35. Yeah, but
14 and 5.
we're looking for groups of 5. That's why the last time was 5 times 2.
Okay.
And so since our period is 5, we're just trying to see how many periods go into this. So
5 times 14.
yeah,
So, sorry.
yeah, no problem. So I think that what you did worked because, well, let's talk about why it worked. Why would this work?
It's really focusing.
Because 35 is
Yeah.
14 5s.
Yeah, there's a 5 in there already.
Wait, oh, wait.
Yeah, well, that's it. There's 7 5s, so there's
7.
yeah, so there are 14 groups of 5 here. So that's what you're asking yourself, like how many groups of 5 are in there, and then go that many back. And then that 2 comes from the remainder if you're dividing. What do you think, Simon? Does that make sense?
Wait, how do you just?
We're just dividing this by 5. How many times does 5 go into that? It is 14 times.
And then you get the remainder
Remainder
of
is two.
C on the, like you, is the remainder like the X value you go to?
Yeah, exactly.
Okay.
That's why we're going to G of 2. G of 2 is
Okay.
6. And max and
Our
the
remainder was like 2/5, so do we go to 2?
remainder was 2/5.
The remainder is 2, but
Oh, if you're writing it as a mixed number, it'd be 2/5,
Oh.
but the actual remainder
Oh, it's 2.
is just 2.
Oh, so you just go to 2x, or
The G of 2.
Yeah.
Oh, G of 2.
Just G of 2.
Oh.
And I'll make that perfectly clear here. And yeah, I promise I'll call you right after I write this. Yes, yeah.
Amount of periods that you're going back or forward by relevant right now.
It's a method. It's a way to get our answer.
But I feel like this amount of work for dividing like 72 by 5, like, that's not something necessary that you need to do, right?
There is, you could do it more intuitively. Like, honestly, I would probably do something like just 2 plus 70, understanding that every 5 is the same one. Would that make sense?
Yeah.
So I don't care how many 5s it is. I know that that's a multiple of 5 and it's just 2 away from it. So that's kind of how I would think about it. Right?
2 plus 7. So think of it like that.
What's that?
2 plus 70 or 2 times 2 times plus 7 is more 5.
Yeah, I'm just trying to find the nearest multiple of 5. Well, one way. And again, that just remember it's repeating forever. So you can go back 5, one group of 5 at a time, but when you're up at 72, that's pretty far. So that's why we just divide how many 5s actually go into that 72. 14 will take you back to the 2. Yeah, but then we get to that negative, G of negative 17. Who'd like to tell us about that? Yeah, Nathan, what'd you do?
Good, cause like 5 times 3 or
Mhm.
7 or is 15 with like remainder 2 basically.
Okay.
It's negative obviously, so if you go back 3 cycles, I didn't really write it, I just like thought of it in my head, but go backwards 3 cycles, then you have to go -2. So instead of going from the front
Oh,
of the
so
cycle,
just a minute. So this is like the same as G of negative 2?
yeah.
Do we agree with that? Does that make sense? So you just moved up 3 cycles, 15.
Yeah,
Okay.
and then I just I started from the beginning of the cycle and went backwards, so basically as if you went from 6 to 4.
Okay. Well, I think once you're at G of negative 2, we have the graph. You can
Yeah.
see the G of negative 2 is 7. That's one way. Okay, yeah, Emma and then Jonas.
No, what if you didn't have that part? Like, what if it didn't show GFN?
It's like yeah.
Well, remember, this is periodic, so you could just copy and paste this. This over here. And Jonas?
So that's.
Okay, what'd you do?
I did G of, I said, I was thinking of it as less than, as less of 15 plus 15 minus -15 minus 2 and more of -20 plus 3.
Ah,
I just
so
get G of 3 instead of G of -2, and that's the same thing, but it's.
okay, nice,
That would.
perfect.
The way you solve it, yeah.
I love it. Yeah, that's great. Yeah, Simran and the Max.
If you get a remainder that's like bigger than like what you can see as like the X values, can you just keep dividing?
Yeah.
Oh,
Exactly. And who knows what portion of the graph they're going to give us?
Yeah.
There's always going to be some sort of twist.
so just keep going.
Yeah, just keep going. And once you have the concept, it really shouldn't be too big of a problem. Max, do you have something else? A
The
question?
reason why we divide the number by 5 to like simplify it, but why do we divide it by 5 but not add 1? Because like this thing like starts like 1 later.
Hmm.
Like the periodic thing that we're measuring, it starts like with 1 to
Period can be anywhere.
Yeah, period could be anywhere.
Fact that from 1 to like G of 1 to G of 6, it's the same thing as it's the same image, but if you moved 1 back, it would cut the same amount of image that you could repeat. Like we just see it from those points where it dips because that's what's easiest for. But I don't think that helps.
No, that was good. Well, let me take it back here. The G of 14. let's just go back one period at a time. Does it make sense, Max, that this would be the same as G of 9 because the period is 5? Or are you trying to add one to this?
Wait, how is it G of 9?
Because 14
14.
minus 5 is 9.
Oh,
And then,
yeah, and then if you subtract another 5.
yeah, then I can make this G of 4. Yeah,
Oh.
exactly, it's repeating. So this is kind of saying, I'm going 2 back, like I could go 2 back to get that same 4.
Wait, so then if you took 14 and divided it by 5, it would be 2, 4 over 5. So
Mhm.
you would just go to 4 and then you would get 7. Oh my. Wait,
14
that makes
divided by
sense.
5, yeah, you get the 2. Yeah, remember this, that
That was.
that's
that
what
was
I want
last-
before. Yeah. Did I do this? Did I do that wrong? I think I did that wrong. This is a 14.
Wow.
14 oh, it is, yeah, it's remainder 4. That's why it's 4 right there.
You can just do subtraction if the number's pretty small, and
Yeah.
then that's how you do it.
Perfect. Yeah, and you could still do, you could do minus 5, minus 5, minus 5, minus 5, minus 5.
Yeah,
That's annoying. That's why you figure how many 5s are in there, the 14,
yeah,
and then that's gonna take us back to
and then
2.
do you do addition there because it's not, for the negative sign here?
That's one way to think of it.
Mhm.
We're deconstructing this 72 into a way that we have a meaningful start, and then understanding that all these periods will just take us back to
Yeah.
the exact same.
Okay.
Someone else would like to talk about C where they got the 7?
Wait, I think I could do it now.
Yeah, what would you do?
Okay, so I would take negative 17
Uh-huh,
divided by 5.
Okay.
That's our period. And then I would get negative 3, remainder 1.
okay, remainder 1, remainder 2, right, remainder 2.
And then.
Well, it's remainder negative 2, right?
Yeah, it's remainder negative 2. And then with the remainder negative 2, I would just go to 0 on our graph and go 2 backwards.
Okay,
And then I would get 7.
okay.
Okay.
Yeah, I'd probably go from G of negative 2 to G of 3.
Oh.
Would that make sense to bring it up there? Why could I do that?
Oh, because it's plus 5.
It's 5 away. It's just 5.
Math is like a circle and we're just all around it. This,
I'm gonna get a tattoo of that on my whole back.
I know someone who has a circle of this tattoo.
Circle of what? Fifths? Oh, and musician, I guess.
Music and math are very correlated.
Yes.
Maybe because they both start with M.
That's definitely why.
Yeah,
Yes.
definitely.
That's why I love marmalade. Okay, moving on. And McDonald's. Yum. Okay, example 4, the graph of H is periodic with a period of 5. Values of H are shown as selected values of X. Find the following values. Do it. Discuss with your neighbor that first one first.
All right, neighbor.
Oh my
I
God.
already did. Look at me.
For H.
It's not.
So you can negative. Because if. It's negative 2. 3. Which is 5, so then, right? It's the X by 4. I got it all. The bottom. What's negative 2? So it would be negative 2. I think it would be. Oh, except for that. This is the. Minus.
Yeah. Oh, it says period of 5. 13.
I guess it's great.
B is negative.
Oh, you ready? Negative 2 plus 5. 7. Nope.
Yeah, no.
0. I got it.
Give me a high
Keep it
five.
out.
It's like,
I'll teach
whatever.
you.
Wait, this is mine.
It's 2.
It's just-
6 minus 5. Negative 2. You get negative 2.
Yeah, like if you put in like 1. I think that makes sense. It's just like. To get the condition.
H of 2. Oh, 2 and 6.
Are we about ready? Just do A, B, and C.
Do you have a?
Actually,
Adding to D.
One plus nine.
I'm doing A, B, and C.
A, B, and C, just not D.
H of 4.
Okay, can you please show me what you got for h of -2? Show me what you got. Okay, so
Makes sense.
0. Are we good with that? Because it's the same thing as h of
3.
3. I just move up 5 to that up. Respective is the corresponding place. So maybe for this one, I'll say h of this is equal to h of 3, which we know by that chart is equal to 0. Can you please show me h of 6? Okay, I'm seeing a very Usher move, 8 down, yes, or -2 perhaps. And this came from the fact that h of 6 is the same thing as h of 1.
But how do we know that?
There's 6 minus 5.
6 minus 5.
The period is 5. So h of 6 equals h of 1 equals h of
Oh, wait, I get it.
equals h of 11.
-4.
H of -4, that's equals h of -4.
Yeah.
Going up 5 or down 5. And the x value, and then the y value will be the same. Okay, I need some help with this one. I'm going to ask for help from the one and only Chloe. Can you help us out with this one, please? H of 9.
I like subtracted 5 first, so it's h of 4.
So you made this h of 4. Okay, I like it. Okay. Oh, that's good times. Any questions? Okay, this next one. In this case, did you get it? If you have it, can I see the answer, please? Nice. We have like a little swath of people here. I'm going to talk about this one. And first thing I'm going to do is I'm going to just kind of reorder this. So it's a little bit more familiar to us. Now, how does this help?
yeah, it's just the period.
Yeah.
5 is the period. So
5 is the period. Now, how many periods? 1, 2, 3, right? K is an integer. So we're just going up or down a set number of periods from this -3. That's why this is equal to
0? What would happen if
h of -3, which is equal to
2.
h of 1, isn't it?
H of 2.
No, h of 2.
And then
Because it's h of 2, and then you add another 5 to that, and you get h of 7.
Oh, h of 2, yeah, I had to add 5 to it. Yeah, I don't know this one, but I do know h of 7 is 2. Thank you. Yes, Simran?
Got rid of 5K.
Yeah, because we know that this function is periodic. How do we know it's periodic?
because it says
It says it's periodic, right? It says a period of 5. So let's say I start with 2. I know I could add to that multiples of 5. This is
Yeah.
the same thing as 7, is the same thing as 12, is the same thing as 17. I could add multiples of 5.
Yeah.
So that's all this is saying. We're starting -3 and adding a multiple of 5.
Oh, 5 into period times
Five.
whatever.
Perfect, exactly.
Oh, okay.
Yeah, so you just simplify that to be that -3, and then we bring it into the space.
Because
that
K
we
can
got.
be 1.
K could be 1, 2, it can't be 0.3. It says that K is an integer. So that's a little bit tricky there, Chloe. Oh, that was nicely said, yes. And I hope it makes sense. Once you think about it that way, it has to be an integer. We're counting full periods here. Good. Great connection. Thank you for that. Okay. According to this, I hope it makes sense. Well, we're able to consider a periodic function as a horizontal translation of itself. So horizontal translation of itself. Like this is saying that the function is itself shifted 5 to the right, isn't it? 5 to the right. Or really 5 to the right or to the left. Is this really 5 here? Oh, this is different. I'm sorry. Yeah, this is, I wish that it would connect here like that. So for this one, we could say that f of x is equal to f of x
Minus
five.
4.
-4, right? Because that period is 4 there. And what we could see here, I think one way to visualize this is to get f of 5. Isn't that the same thing as f of 1?
Yeah.
Or f of 6 is the same thing as f of 2. It's a translation onto itself. So for what it's worth, that's what it would look like. The graph of f is periodic with a domain of all real numbers. Two full periods of f are shown. Find all input values of f that yield an output value of 1. I'll give you a moment to think about that.
So 2.
2, 6,
6
10.
and
14. Output value is 18.
No, I like that.
2, 6.
oh wait, x minus 4 equals 2.
Yeah.
X minus 4 equals 2. So x when x equals 6. And when
It's all.
Hey, this has to start with x equals. The first answer is 2, but I want all the answers. So to this, I'm going to
Plus
add
4. Plus
4 k. K is normally what we use when we're talking about numbers of periods. If k is 1, that means we're at 6. If k is 2, that means we're going up 8. It gets to every dip there. And if k is -1,
You go -2.
it was -1, -2, -3.
plus
Say that again.
6.
It could be 6 plus 4.
It doesn't matter.
It doesn't matter where you start, as long as we have one value that has a y value of 1. Actually, that's a really nice idea.
Oh.
That was 6.
You can just do negative.
Yeah.
Wait,
Well, yeah, we
Yeah.
could write -4k as well. Normally, we just say +4.
yeah.
But k could be plus or minus. And here I'm going to qualify k by saying that k is an element of, what is the abbreviation for integers? You remember? You remember that
Is it not all?
letter? I'm just wondering, the abbreviation is like all real numbers would be this, but it's not all real numbers. It's not all real numbers because that could be like 2.6. We want full periods.
I think I got it. Eureka.
That's not a letter, but thanks for playing.
Oh my god.
Oh.
So the letter for integers,
I'll definitely use to.
That's Q.
Wait.
Z, there you go. Thank you. This comes from what language?
Oh, Greek.
Latin.
Roman.
German.
German.
Zahlen.
But German.
Zahlen.
German.
That's standard for integers. It's gotta be that. You can say case. Okay, here we have it. It's time for this problem.
Oh my god, I hate prom.
Please read to yourself as I read aloud. Yeah, clock suck. Example 6. The figure shows a large clock mounted to a vertical wall. Let's listen, please. On this problem. So the clock shows a large clock. The figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving minute hand. The center of the clock is 120 inches directly above the floor. At time t equals 0 minutes, the minute hand is pointed directly up at 12. However, the clock is not working properly and the minute hand is moving twice as fast as it should. Not an effective clock. Thus, the next time the minute the hand points directly up to the 12 is at time t equals 30 minutes. As the minute hand moves, the distance between the endpoint of the minute hand and the floor periodically decreases and increases. Does that make sense? We're talking about the distance from the tip of the minute hand to the floor. The periodic function h models the distance in inches between the endpoint of the minute hand from the floor and the floor as a function of time t in minutes. I'm sure there's an extra word in there. We're just trying to go from the floor to the top, the tip of the minute hand. Okay, so this graph is the graph of h, and its dashed midline for 2 full cycles is shown. 5 points are labeled on the graph. No scale is indicated and no axes are presented. I'd like you to determine possible coordinates of each one of these points. Maybe you can discuss with the neighbor the first one and then go through the rest on your own.
At the top, or. Yeah, that's the.
So I guess it's.
Here's like. Add it like 5 seconds. It's like 128.
Doesn't get to 12.
Yeah. It's 128.
It's directly level.
Yeah.
Oh, yeah, wait, okay.
Is- do you add-
20 in.
Do you add the 8 inches?
Yeah.
You're right.
Yeah, right.
Yeah, yeah.
Right, you add the 8 inches.
Oh my god.
Yeah, you put it in the code.
Alright.
How do you know it's?
Oh.
That's the, so in total, it's 128.
Yeah.
I technically zero the minute. There's that 12.
Oh, wait.
But 2 minute.
Maybe we're not.
Twice as fast
No,
as
of
it
course.
should.
You're right.
That's the-
Okay,
I can sound it out.
so I'd like to know what you got. Augie, what'd you get for F?
I got 0, 120.
Do we agree that's an acceptable answer?
What?
Is it 0 okay?
Yeah, I thought it was 128 because you add.
Do you?
Oh, yeah, you're right, it's 120.
128. Are we good with that?
Yes.
I like that.
Does it have to be 0, 128?
No, it depends on your point of.
Depends on, yeah, kind of when you get there. It could be 0, it could be 30, 60. Let's start with 0 just to be consistent. I would like to call on someone for the export. Are you ready for that already?
Wait, we're not ready.
Oh,
You guys are. Take a look at key.
Which is half. So this is halfway. What is the?
Okay, I would just like to know the next ones. Who'd like to tell me the other ones? Yeah, Judy? 15, 125? 15, 125, okay. Or 120, excuse me.
Wait, 15.
I thought it was 112.
I thought it was 12.
Why is it 15?
I thought
That's G, that's on
The next.
G's 112, right?
No, G's on the middle. Then J.
Uh-oh, we have controversy. Yeah,
Oh, you're right. Yeah. Yeah.
Wow, I think it's like.
oh, P.
This is, I was thinking about J.
Yeah, I think that's an important one to do, isn't it? The 3128.
Stats.
I don't.
It's like. Wait, that's right.
No, see, look,
Let's bring it out.
So G, the X coordinate. Judy, do you want to change it, what it is?
James.
15/2 or 7.5. Are we good with that?
15, 120.
Judy, you want to continue?
Eight, 2.5, and 120.
Are we good with these? Thank you, Judy. Yeah, I don't know how they made it like this is such a super broken clock, 30 minutes per hour. It's weird, but yeah, this is right.
Those makes sense.
I don't know why they put a J there. There should be an I. Okay, continue with B. Both parts.
Like 1 minute.
Be careful.
C1, C2.
Yeah, B1 and 2. One is multiple choice. 2 is free response.
Hey, Rose, Henry, this is the thing that you helped me with, but now I'm forgetting.
You got this. I know this.
It was negative in this.
Negative and D.
Yeah.
I thought it was negative in first.
No, negative.
I don't think
So why?
Wait, looks like it's. Oh, wait, it is. Yeah, that's true. Oh.
Which
I
one?
mean,
Oh.
Oh, Mr. Bright.
Dropbox network. He has like tasks for like each of these, and some of them have like, oh, here's a wheel. Here are like 4 rotations every minute. So like it previews like a frequency where the kid, wait, the period's 1/4? Yeah. And they have to work with it. One of them is 1/50. Like there's some cool.
Very cool.
Yeah.
Oh, wait, yeah, so it's. It is negative.
Okay, folks,
Oh, I think it is increasing.
let's talk about it. Do you remember your American Sign Language ABCD? A is A. A is this. B. C. Not this. It's this. D. B is this one. Right? So you can see the D there, but this is this. So A, B, C, D. What's your answer for D1?
Oh, that.
So I'm saying B's, C's. Thank you for that, Simran. I'm seeing B's and C's, and I think I see some D's too. So who'd like to tell us what they thought about this? Yeah, Jonas.
I think it's B because if you look at G to J,
Mhm.
it looks like a concave up graph, but it's decreasing, but it's positive. But the rate of change, wait.
We're doing just part 1, right?
Actually, maybe.
I thought it was.
Yeah, Lee.
I mean, I thought it was C just because like we can, from the values that all of the section are positive. And
Yeah, these are all positive.
just going down, goes from 120.
Yeah, this is very superficial. It's very looking at it like these are all positive because this clock is above the ground. So these can both go, and it's decreasing because it's getting closer to that. Yeah. So you're exactly right.
And it's not the rate of change.
And we're not talking about the rate of change there, but yeah, 2 talks about the rate of change. Like, how is the rate of change of H changing over this interval, that same interval? Yes, Haley. Okay, so wait, so rate of change is increasing, or it's negative. I think maybe that comes first. Negative. Do you agree with that? Rate of change is
No, it's. Yeah.
and increasing.
Yeah.
But it's concave back.
No, it's not confident.
Oh, no, she's right. She's right. Gaslight, I was right.
Yeah, but.
Hey, this is not.
Nice. Yeah, normally we start to talk about the just the rate of change, positive, negative first, and then talk about if it's changing. But and we are just looking for this because it's talking about how's the rate of change changing. Yes.
So we got her.
You explain a little more because, is it negative because
Are you talking for 1?
2?
Okay.
Because the Y value from G to J decreases?
That's perfect. Yeah.
So then what's increase?
Well, increase would be like from K to P. Yeah, that's not too. It depends what you're talking about increasing. The function is increasing from K to P. But the rate of change, like from K to P, would be decreasing because it's concave down.
Yeah, so, oh, I understand.
Yeah, so we're just looking right here. Since it's concave up, the rate of change is increasing. Just by seeing. Okay. Are we good? Okay.
Yeah.
That's all I got for you for today. So you have some time to take out your assignment and go ahead and get started on that.
Yeah.
It's like, I thought about it too, like, it's not like